Integrated Math 3, this is assignment 2.01. It's the first assignment of Unit 2, which deals with polynomials. Let's talk a little bit about what a polynomial is. A polynomial is anything that has even one term is considered a polynomial, even though a polynomial, poly means many. So these are called terms. This is a coefficient, variable, exponent. And there's a whole variety of different combinations, but we're not going to get into the formal definition of a polynomial. Just recognize it as equations that are set up or expressions that are set up looking like this. Okay, so we're going to go ahead and add these numbers. So what it's asking us to do is, what you want to do is, the way I like to do this is I set up a column for each exponent. This is called the order of an equation. It's the highest number polynomial. So this is a second order polynomial. This is a second order. So in order to add two terms in a polynomial, you must have the same variable and the same exponent to add terms or subtract terms. So we're going to go ahead and I'm going to put a 2 up here. I'm going to put a 1 here and a 0 here. Okay, now what does the 0 mean? Well, the 0 means there's no variable. You could express the number 6 as 6x to the 0 power. You might remember that x to the 0 power equals 1. So that's the same as saying 6 times 1, which equals 6. So this can be treated as an x to the 0 power. So that's going to be this column right here. All right, let's go ahead and just line things up. So 3x squared and 4x, so that's 4x to the first power. If you don't see the exponent, it's the first power. So it's 4x, and then finally we have a minus 1 over here. Now we go to this expression over here, which you're adding. It's 8x squared. You have minus x, and then you have plus 6. Okay, so when you add, the term stays the same. The x squared stays the same. So it's simply 8 plus 3 is 11 x squared. 4x minus x is 3x. And negative 1 plus 6 is plus 5. Now some students may think that 4x minus x is just 4. Maybe the x goes away. So the way you test that is just pick a small number and do a little test on it. Let's just say, I'm just picking a random number, but you want to pick one that's small, but not a 0 or a 1. And I recommend you do this if you're not sure about a mathematical relationship with variables. So let's say that x equals 2. And maybe you thought that 4x minus x is 4. Maybe the x gets subtracted and just goes away. And that's not true, but let's prove it. So 4x is 4 times 2. Minus 2, that would be, the x would be 2, and that would equal 8 minus 2 would be 6, and 6 is equal to 3x. I'm ignoring, that should have been a plus sign, sorry about that. That should have been plus. Okay, so 3 times 2 is equals 6. Okay? Okay, so that's a way you can test out variables. So there's our answer, corrected the plus sign there. If you caught that, good for you. So 11x squared plus 3x plus 5. Let's go on to the next one. All right, next one is a multiplication. You're multiplying every one of these terms. I'm going to show you 2 ways to do this. Some students learned a different way than I was taught, and I still teach the way that I taught. I simply do this. First of all, you need to understand the principle of exponents. So what is x squared times x squared? So you need to understand this principle, that x to the a times x to the b equals x to the a plus b. Again, let's prove it. Let's use 2, 3, and 4. So a equals 2. I'm just picking some small numbers to test that on. B is 3, and C is 4. So if we take A if we take a equals 2, so let me write the number actually. So 2 to the 3 times 2, put a dot for times, to the 4. This equals 8, 2 to the 3 equals 8, 2 to the 4 equals 16, and you could do this on a calculator, multiply those and you get 128. Alright, is that the same as this? That would be 2 to the 3 plus 4, and that's going to equal 2 to the 7, which equals 128. I'm going to show you how to do that on a calculator. How do you do an exponent on a calculator? Again, you need to have an actual calculator. If you have a cell phone, it's not going to do everything we need to do in this class, so I would recommend getting one. Unfortunately, we don't have a class set that I can share with you. But what you do is 2, and you use this little hat sign. It looks like a little hat or a little upward arrow. It's actually called a caret. So you use 2 caret. I'm trying to keep this in focus. And if I put 7, that means 2 raised to the 7th power. And I hit equal on that, and I get 128, which is the number that I have there. Okay? All right. So let's continue with this problem. So the way I do this is x squared. What's that going to equal? X squared times x squared is going to equal x to the 2 plus 2, which equals x to the 4th power right there. So that's what that part is. So what you do is multiply the coefficients, the numbers out in front. First of all, what you do is I know it's going to be x to the 4th. So I'm going to have an exponent of 4. I'm going to put a 4, a 3. All my exponents of 3 will be there. All my exponents of 2, 1, and 0. Okay, now I'm ready to get started. So 6 times 2 is 12. You just multiply those two numbers. And x squared times x squared is right here. We just did it up here. It's x to the 4th. So I'm going to put that in the 4 column. All right, next. What you do is you multiply each of these. So I'm going to do this, this, and this. There's going to be 9 multiplications you're going to have to do here. So the first term in the first polynomial multiplies with each of the terms in the second polynomial. So now I have 6x squared plus 5x. X squared times x to the 1 is x to the 3rd. That's x to the 2 plus 1 is 3. And 6 times 5 is 30. So that's going to be 30. I don't need to put the plus sign right here. We're going to do the adding here in a minute this way. So that's 30x squared. Okay, and then 6x squared minus 5, that's going to be a negative number. 6 times negative 5 is negative 30. And there's no x term over here, so this is the only x term you have is x squared. Okay, there's no terms for 1 and 0 for this first one. Now what we're going to do is we're going to do this. I'm going to make these really, see, you're going to have one go like this. You're going to have one go like this, and you're going to have one go like this. So here we go. There's going to be a minus sign here, so it's going to be x times 2x squared. That's going to be 2x to the 3rd. So that's a 3rd power. I'm going to put it right here, 2x to the 3rd. And there's a negative sign. It's negative times positive. You imply that there's a positive sign in front of the 2. So that becomes negative 2x to the 3rd. Now it's going to be x times 5x. So x times x is x squared. And it's a negative positive, so it's negative. So that's going to be negative 5x squared. All right, and next you have x times 5. That's just 5x. But you have negative sign becomes positive sign. So you don't have to write the plus sign there. Let's go ahead and do that just to make it very clear. And that's 5x. Okay. All right, now the last one, I'm going to erase these lines. I don't need them anymore. Otherwise, you'll have crossing lines that'll be all over the place. Then it's going to be the last term times this, and times this. So you just have each one of these take turns. This multiplies all of these. This multiplies all of these. This multiplies all of these. So now I have 4 times 2 is 8x squared, and there's a negative sign there. So I need to go to the x squared column. Negative 8x squared. Now I have 4 times 5 is 20, negative 20. There's a negative sign. Negative 20x. And finally, I have 4 times 5. They're both negatives. Negative times a negative is a positive, so it's plus 20. That's the first term I have down here in the 0 column. Now you simply add. So it's just like regular multiplication. You do your multiplications, and then you add down at the bottom. So 12x to the 4th. 30 minus 2 is 28x, positive 28x squared. Okay, negative 30, you're going to go in the negative direction 5 more, that's negative 35, and then you're going to go in the negative direction 8 more, that gets you to negative 43. You do that on a calculator if you're not real comfortable with negative numbers, okay? And I'll show you how to do that. Okay, it's going to be an x squared, so let's just focus on the coefficients here. Watch what I do. If I'm on this calculator, I don't use a minus sign for a negative number. I use this. This is the symbol for a negative number here. Let me get this in focus for you. That's the symbol for a negative number. So up at the top, I'm going to have negative 30. And then it's going to be plus negative 8, but we're just going to say minus 8, or minus 5 rather. Minus 5, and then minus 8 more. And that gets you to negative 43, okay? So when you see these minus signs, you may say, well, are they negative signs for the 5 or are they minus signs? You can treat this as negative 30 plus negative 5 plus negative 8, but that's kind of adding a complication to it. You don't want to do that necessarily. So we're going to just say minus 30. You start at minus 30. You go 5 in the negative direction to negative 35. You go 8 more in the negative direction to negative 43. Okay. All right, the last one, the second last one is 5 minus 20. Again, you can do that on a calculator. And that's going to get you negative 15 for x, and then the last term is plus 20. Okay, I'm going to show you a different way to do it, and this is the way some students like to do it. You may see this as your preference, but it gets you to the same place. Alright, so I'm going to take this first polynomial and I'm going to write 6x squared minus x, kind of space things out a little here, minus 4. And then down the side here, I'm going to draw a line so I don't spill over there. I'm going to write 2x squared plus 5x. You'll find you're doing the same thing with this one. It's just organizing it a little bit differently. Okay, so what you do is you simply multiply these two and you get the 12x to the 4th. Now you multiply these two and you get negative 2x to the 3rd. These two. Okay. Now you come down here. And you multiply these two, so 5 times 6 is 30, and then it's x squared is going to be x to the 3rd. And then you multiply 5x times x, that's going to be times negative x, that's going to be negative 5x squared. Again, x times x is x squared. And then finally 5x times negative 4 is negative 20x. And now you come to this last one. Negative 5 times 6 is negative 30, and then there's the x squared term. Negative 5 times negative x is positive 5x, negative, negative. And you just have to be careful on the details because there's so many calculations to do. That is a plus sign there. And then negative 5, negative 4 is plus 20. Okay, now you can't add this way because you have different terms, 3, 2, 1. But what you do is you do diagonal lines like that. And you'll notice the x squared term is there, and that should have been an x squared there. So the x squared terms go like that. the x terms go like that, and they're like that. I don't find that any kind of advantage to doing it that way. So you'd have 12x to the fourth. Okay, so I left the x squared off there. Be sure you correct that. That's why I say you can make a mistake easy. There's the x to the third terms. So it's 30 minus 2 is 28, positive 28 x squared. Okay, and then it's negative 30, negative 5, negative 8. We did that one already. It's negative 43x squared. And that should have been x to the third. It's these two right here. Okay, and then there's the negative 43x squared. And then here's the negative 20 plus 5x. And then here's the plus 20. So you get the same result. Some students like to do it that way. That's fine. It's your choice. I'm going to show you using this, okay? Because I think these diagonals can get confusing. You saw I got a little confused there. I think they can get confusing, and I don't like it. Okay, I do it this way. Just line up. These represent the exponents on the variable. Okay, so let's move on to the next one. Okay, here's a subtraction. The first one was an addition. This is a subtraction. The way you deal with this is you got a minus sign out in front of this polynomial here. So what you're going to do is get everything out of the parentheses. So this whole polynomial you can take out right away. It's the same as just saying this. Now what this is going to do, it's going to turn around every sign that's in here. So there's a positive sign in front of this 2, even though you don't see it. So that's going to be minus 2x to the third. Okay, and then the negative sign is going to turn this around. That's going to be minus 6x squared. And then the negative negative is going to be a positive. Positive 11. Positive 11. Okay? Okay, so now we're going to go ahead and we're going to set up the equation the same way we did the first one up at the top. So the highest order term I see is a 3. So I'm going to put a 3 over here, and then we have 2, 1, and 0. Alright, so I'm going to go ahead and put these terms in. So the first one I'm going to go ahead is 4x squared. Okay, now over here we have an x to the third term. So we're going to come over here and put it over here. And you'll notice there's no x term here. There's an x squared and then it goes to x to the 0, or just no x there. So there's no x term. So you're going to just leave that blank right there. And you're going to come over here and say plus 11. Now that I have taken this and put the minus sign along everything here, this whole thing becomes an addition problem. So I'm adding. So 0 plus negative 2x is negative 2x to the third. 4 minus 6 is negative 2x squared. Negative x plus 0 is negative x. And negative 7 plus 11 is positive 4. Okay, and there's your answer right there. Okay, let's go ahead and do number 4. So we see that the highest order term is a 3 there and a 2, and you're going to multiply. So remember how this works. This one goes to that first. So x to the 3 times, the dot is a times, x to the second equals x to the fifth. Remember, we add those two. It's x to the 3 plus 2 equals x to the fifth. Okay, so that's going to be my highest order term. So when I come over here and set up my columns, I'm going to have a 5. Okay, so let's go ahead and get started. So it's going to be this to this, this to this, and this to this. I'm going to do this one silently so it'll speed ahead a little faster on the video. Okay, so here we go. Okay, now I'm going to stop and check my work. Okay, so I checked my work and I realized I had put a plus sign there. You probably see that if you copied, and that should be a minus sign. So I recommend checking work every step along the way. There are so many calculations you're going to make mistakes. I'm going to make mistakes. Everybody's going to make mistakes. Okay, so now we're ready to add. The 5 here is -10 minus 5 is -15. You start at -10 and you go in the negative direction 5 places is what that's saying. Okay, a lot of terms there, okay, a lot of stuff going on there. All right, okay, that's your answer. Okay, I'm going to set this one up for you. Go ahead and see if you can do this. This is the only tricky part, and then after that you're going to add all the terms. Okay, so we've got this. Okay, so we just put a minus sign. We just reversed whatever the sign was here. They all happen to be plus signs, so they all became minus signs. You reversed the sign. Okay, what's the highest order term we have is x to the third. So I'm going to come over here and I'm going to write 3. Okay. Now, let's make a comment about this. There's something called standard form. Standard form means that the terms are in the order of exponents from biggest to smallest. So this is in standard form. 3, 2, 1, 0. You could have skipped a term. There might not have been a 4x term here, and it still would be standard form. But this is called standard form. Okay, and over here is irregular. Notice they're not in order. Generally, you want to put them in order, but you don't have to if you do what I'm doing and setting it up this way. But notice the largest term in this one is at the end. It should be at the beginning, and the 10, the smallest term, should be over there. All right, so let's go ahead and set it up. We can still set it up because we know that our 3's are going to go in the same column. And now we're adding. Now that we've distributed that minus sign, it's going to become an addition problem. Okay, so I put this 4x up here. Yeah, put the 4x up there, the 8x down there. It doesn't matter. Once you have them out of parentheses like that, you have the signs attached to them, it doesn't matter whether I put the 4x above and the negative 8x or minus 8x below, or the other way around. It's going to give you the same answer. So let's go ahead and add these. So 7 plus negative 3, or 7 minus 3 is? Okay, and the 10s go away. Okay, so I'm going to check my work. Okay, checked my work. It looks good, so this is our final answer. Okay, if you disagree, let me know. All right, I'm going to leave 6 for you to do. So when I give you an assignment like this, first of all, I give you most of the credit if you just do most, but not all, more than half, if you just do the ones I do. But to really get all the credit, I mean truly passing credit, you have to do these on your own, okay? You should be able to do this one. Notice that this is not in standard form, but as long as you line it up like this and be sure that the minus 2x to the fourth and the 5x to the fourth go in the 4 column, it doesn't matter. Okay, so you're going to go ahead and do 6 on your own. All right, so let's look at this one. This one's going to require that we distribute. Distribute means that you take this and you multiply it by everything in here like that. Similarly, you're going to take this and multiply it by everything here. So whatever's outside of the parentheses multiplies everything that's inside of the parentheses, okay? So it's basically two multiplication problems, and then you're going to turn it into an addition problem. So let's go ahead and lay this out. So look for what the biggest term would be, and it's going to be y squared, y squared. This time we're using the variable y, it doesn't matter. X, y doesn't matter. But what we notice is it's only one variable in this problem. So it's y squared times y squared equals y to the 2 plus 2, which equals y to the 4th. I'm trying to draw my y the way they drew the y looks there. Okay, y to the 4th. That's to the 4th power. Okay? Alright, so let's go ahead and do this. So 8y squared times y is going to be 8y. See if you can do this. I'm going to write my y's the normal way now. 8y to the 3rd, 2 plus 1. Whenever you multiply base times base with exponent, you add the exponents. 3 plus 2, 1 plus 2 is 3. Okay, now 8y squared times 6. You can do a calculator if you need, but you should know 8 times 6 is 48. Y squared. Okay, so we've taken care of that. Now what we're going to do is we're going to distribute this through to here. So over here we have a negative and a positive, so right away that's going to be a negative. 6y squared is going to be negative 6y to the 3rd. You add the exponents there. 6y, so it's a negative negative, so it becomes a plus. Then the next thing is 6 times 6 is 36. And then the next thing is y times y is y squared. Okay, and finally, we have 6y times negative 6y times 4 is going to be negative 24y. Okay, again, go back, check your work, which I'm doing right now. Okay, looks good. So now our highest order is the 3, so we're going to write over here 3, 2, 1, 0, and the y to the 3rds go there. Again, it doesn't matter which one goes on top or on bottom, you're adding everything over here. So it's y to the 3rd, and it's negative 6y to the 3rd, which means it's basically a subtraction. Next one is y squared, so it's 48. And 36. Okay, and what you can do is scratch them off as you do them. And we only have one term left, it's minus 24y. It doesn't matter whether I put it up here or down here, I'll put it up here. And there's no constant, every term has a y. There's none without a y, so there's nothing there. Okay, so 8 minus 6 is 2y to the 3rd. Add these two numbers together, and you get 84. And that's the answer for that. Okay? But be sure you can do this on your own. Alright, let's keep going. Okay, for number 8, I'm going to let you do this one on your own. It's just like the last one, except a little bit easier, not as many variables. And your variable happens to be C, so you're going to distribute that, and write those terms down here. Then you're going to distribute, remember everything's a negative, it's going to flip all the signs because of the negative. Negative 5 times that, negative 5 times that, negative 5 times that. And you're going to get those. So you're going to end up with 5 terms down here, and then you're going to line them up. I'll just help you. Your highest term is going to be a squared, that's c squared. So you're going to have a 2, a 1, and a 0. You're going to line up your terms there, and you're going to come up with an answer. Okay, so that's one I'll check for you. So you do that one exactly the same as number 7. All right. Now we have what's called a FOIL problem. First, outer, inner, last. So first you multiply the first terms. Then you multiply the outer terms, then you multiply the inner terms, and then you multiply the last term. Okay, this is actually easier. This is just like the multiplication we did earlier, except a lot easier. So you're going to basically have first is x squared. The second is x times first outer, so x times negative 12 is negative 12x. The inner is 3 times x. And the last is 3 times negative 12 is negative 36. The only terms that have a similar variable exponent are the x, so you can add those. You can't add anything else. So negative 12 plus 3 is negative 9. So your answer is x squared minus 9x minus 36. Okay, let's do the next one. This actually, after the earlier problems, is actually kind of an easy problem. The only distribution you have to make is 2 to the y and 2 multiplied by that. So we have 2y minus 14. Okay, now that we have that, now we have a second multiplication like this. You would find, if you wanted to experiment, that you could have multiplied the 2 by everything over here. We're doing 3 multiplications. 2 times this polynomial times this polynomial. When you do multiplication, it doesn't matter what order you do it in. 2 times 3 is the same as 3 times 2. Multiplication doesn't matter what order you do it in. So you could have multiplied this times this. You could have multiplied all of these together, these two terms, polynomials together, and then multiplied through by 2. You could have done that in any number of ways. But I'm just doing it in order from left to right. Okay. So I multiplied this. Now I've got this over here. Okay, so what we're going to do is, I see that the biggest exponent, the biggest term is going to be y times y squared is going to be y to the third. 1 plus 2 is 3. So I'm going to come over here and write 3, 2, 1, 0. All right, and now we go ahead and we do this. So 2y times y squared is 2y to the third, so I'm going to put that over here. Okay, and then 2y times negative 2y is negative 4, and y times y is y squared. And 2y times 8 is 16. And then negative 14 times y squared is negative 14y squared. Okay, and then negative 14 times negative 2 is positive 28, and then you have a y there. And then negative 14 times negative 8, and do that one on a calculator, but I'll tell you that's going to give you negative 112. Okay. All right. So now what we do is just add the columns. Minus 4, minus 14. And there's your answer. Okay, this is called Pascal's triangle. This down here on the bottom, and it has a lot of interesting uses in mathematics and even in nature. We're going to show one of them here, but I want to show you how you can draw it. If you didn't have it in front of you, you can draw it. So what you do is you have a diagonal column of ones going in this direction and in this direction. And what you simply do is the number that goes on the next row in between two numbers on the row above, but the next row down, is simply adding these two. So once you've drawn the column of ones, draw it neatly so it's a nice diagonal. And then what you do is, well, there's only one number there, so you can't add, so it's simply going to be 1. You could think of this as 1 plus 0. You could, since there's no number there, So 1 plus 0 is 1, and 1 plus 0 is 1, okay? But you don't have to do it. Just remember you draw a column of 1s. Now you get down to the second row. 1 plus 1 is 2. And now you go down to the third row. 1 plus 2 is 3. 1 plus 2 is 3. And now the fourth row. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. I'll go one more row with you here. 1 plus 4 is 5. 4 plus 6 is 10. 4 plus 6 is 10. 4 plus 1 is 5. And you keep going like that. Okay? So do a little exercise. Draw Pascal, cover this up, and draw Pascal's triangle for yourself. And go ahead and do that. So do that down below in this space. Just do it down to, I would say, 5 rows. 5 rows is good. That'll show that you understand the concept. So that is a problem. So I'm going to write that here. Build triangle, right? So go ahead. This is just a test to see that you know how to do it. I might ask you to do this on the test, so you want to show me that you can do it. Draw Pascal's triangle. Just do it to 5 rows. Okay, but it's easy to do if you understand that concept. Draw the ones first, and then but draw them neatly. I'd even do it with a ruler to be sure you kind of keep them in alignment. And then I go down and draw the rest. Okay, so let's just see one interesting application. If we have a plus b to the first power, that simply equals a plus b. If we have a plus b to the 0, let's start with this. A plus b to the 0 power, that equals 1. Any number raised to the 0 power equals 1. The only exception is 0, but don't worry about that. Any number raised to the 0 power, well, that's something if you're a mathematician, you'd have to put that condition on. A plus a and b can't both be 0. Or a plus b cannot equal 0, because if they did, that's undefined. But we're not going to go there. So let's assume that they don't add up to 0. So that means a plus b raised to 0 is 1. There's the 1 right there. Okay, let me get the Pascal's triangle back on the screen. Okay, a plus b to the first power, that simply is a plus b. So there's the 1, 1 right there. The coefficient of this is 1, and this is 1. Now, if you did this one, and you did the FOIL, first, outer, inner, last, you'd come up with a squared plus 2ab plus b squared. So look at the coefficients, 1, 2, and 1. That's the third row right here. What you have to remember is the row is 1 more than the power. So this is a plus b to the second power. You go to the third row right there. Let's look at just one more. If you were to do this, that's starting to get messy now, but if you did a plus b times a plus b, you did the FOIL for that, and then you multiplied another a plus b by whatever you got for the first two, that would give you a to the third plus 3a squared b plus 3ab squared plus b to the third. So that would be coefficient of 1, 3, 3, 1. That would be the fourth row right here. 1, 3, 3, 1. Now the way you think of notice there's two variables here, and how do you remember those? Well, you start with a to the fourth, then a to the third, a to the second, a to the first, and then there's no a down here, so that's a to the 0. Think of that as a to the 0. With b, you do the opposite. You start at the other end, and it's b to the fourth, b to the third, b to the second, b to the first, and b to the 0. So that's how you could actually do this. Do this by just understanding Pascal's triangle for the coefficients and understanding how the exponents work. The first one, the biggest exponent, is going to be whatever that exponent is right there. Okay? So what about this one? A plus b to the 5. So I have to come down 1, 2, 3, 4, 5, 6 rows. It's always one row more. So it's 1, 5, 10, 10, 5, 1. So the coefficients here are 1, 5, 10, 10, 5, 1. And you start with this exponent for a to the 5th, a to the 4th, a to the 3rd, a to the 2nd, a to the 1st, and a to the 0. Then from this side you start with b to the 5, b to the 4, b to the 3, b to the 2, b to the 1, and b to the 0. So that's how you could expand any polynomial like that without actually having to do the math, if you understand Pascal's triangle and how the exponents work. Okay? All right. I could ask you to do a plus b to the 6th, but that's torture. So let's do it real quick. So I want you to expand this. So I asked you to draw Pascal's triangle. Watch, we can do it just in a very small amount of space. So let me raise this up here. And all I'm going to show you is Pascal's triangle. So let's do this. So do A plus B to the 6th. So that means we have to come down to the 7th row. 1, 2, 3, 4, 5, 6, 7. And what do I have? I have 1 plus 6. I'm writing the coefficients first. It's this row right here. Plus 15. I'm leaving space for the variables. Plus 20. Plus 15, 6, and 1. And normally you don't write 1 as a coefficient. Oops, I am off screen, I'm sorry. So what I was doing was drawing this. And there you go. Normally you don't write the 1 as a coefficient. Okay, so it's A. So A is going to be our first variable to the 6th. A to the 5th. A to the 1st, you don't write the 1, and then A to the 0, so it's not even there. Now coming back in this direction, you have B to this power to the 6th. B to the 1st, and then no B at all, B to the 0. So there it is. I'm a little off screen here, so let me get over there. So first I just wrote out the coefficients, but I left space for the variables. You could do the variables first if you wanted. And then I wrote the variables starting with this power A, minus 1, minus 1, minus 1, minus 1, minus 1, down to 0. And then B going in the other direction. That's it. So if I actually was going to do A times B, and FOIL that, and then do another multiplication of A times B from that, and then take that and do another multiplication. I mean, it'd take forever. It would take a whole page of paper to do that. So there you did it very simply. Okay, now let's move on to problem number 11 here. And it's just simply a simple FOIL problem, but we're going to do it two ways. We're going to use Pascal's triangle, and we're going to FOIL it. So let's FOIL first. So what this equals to is okay, so first is x times x is x squared. Outer is x times negative 3. Inner is x times negative 3 again. And last is negative 3, negative 3. Okay. Alright, so what you're going to get here is these two combine. So it's x squared minus 6x plus 9. Okay. Now let's try it using Pascal's triangle. It's an x squared. That means we're going to go down to the 3rd row. 1, 2, 3. That's 1, 2, 1. So I'm going to go ahead and write those coefficients over here. 1. Leave space for the variables. 2 and 1. Okay, now with this, the way we're going to write this, remember the form for Pascal's triangle is a plus b squared. So in this case, our a is going to be x, and our b is going to be negative 3. So I'm going to put that in a little parentheses right there. And then I'm going to put the whole thing in parentheses. So what did I just do? This is a, but this has to be a plus sign in the Pascal's triangle. So we're going to make it plus a negative 3. So this is a is x, and b is negative 3. Alright, so remember what we did? We took the first variable and you made it to that power. So it's 1x squared, and then the next one is just x to the first, and the next one is x to the 0. So you don't put the x there at all. Now you start at the other side and you do the b squared. So this is going to be negative 3 squared, and I'm going to put a plus sign in between all of these, even though some of them might end up negative, but They might end up negative. Okay, and then this is going to be b to the first, so it was b to the second. B, you go do the b's going backwards. B to the second, b to the first, so that's -3. So let me write that a little cleaner here, give a little more space. You always want to leave a lot of space sometimes because you don't know how much space you're going to need to write something. So I had 2x already, and then I'm coming back b to the second, b to the first. So in this case, that would just be -3 to the first power. And then b to the 0, which would be 1. So let's kind of clean this up. What's that going to end up? First of all, you put the coefficient there, so it's just x squared. Now it's 2 times -3 is -6x. And then it's -3 squared is +9. And there you see we got the same answer there and there. Okay? So we did it once the FOIL way and once the Pascal's triangle way. Alright, here's another one. So go ahead and do this using Pascal's triangle and the variables. I'll go ahead and do it. Try to do it ahead of me. Otherwise, just seeing me do it, the answer won't stick. You've always got to try it on your own. Find out what mistakes you made and then try to do it on your own. Okay, I'm going to go ahead and do it now. So let's line up what we have in terms of a plus b. It's going to be n plus 4, so there's the a. That's the a, and that's the b. And it's a plus sign, so we don't have to deal with negative signs, thankfully. Okay, so we're going to come to Pascal's triangle. It's to the third power, so we have to go down to the fourth row. Just always one row below what the power is. Okay, so there's 1, 2, 3, 4. So it's 1, 3, 3, 1. That's the fourth row. Okay, this time I'm going to leave myself plenty of space. 1, 3, 3, 1. Okay, and then we start off with n. That's our a. And it's going to be to that power. And n to the 0. Now we're going to start out with b at this end. And that's going to be... b is 4, that's going to be to the third power. Okay, and the 4 to the 0 power is 1. So let's clean this all up. So it's 1 n to the third is n to the third. 3 times 4 is 12. Okay. 4 squared is 16 plus times 3. 4 squared is 16 times 3 is 48. And 4 to the third power, 4 times 4 is 16 times 4 is 64. Okay, you don't have to do what I'm about to do, but I'm going to do it anyway. I'll leave that there. So I'm going to FOIL this, so it's n plus 4 times n plus 4 times n plus 4. I'll do this silently. You can watch me as I do it the traditional way. Now that I've done 2 n plus 4s, I'm going to do the third one. And I can add those together, by the way. I didn't do it. I should have. So that would be 8n. So it's n squared plus 8n plus 16. Okay, and I'm going to draw a line so we don't get confused. I'm going to come up here. So n squared is n to the third. N times 8n is 8n squared. N times 16 is 16n. And I'm not doing this the formal way I did it earlier for the first few problems because I just want to get through it and show you that they're going to be equal. 4 times 8n is 32n. And 4 times 16 is 64. So the terms I can combine, n to the third, that's the only one. Okay, 8n plus 32n. That should have been 8n squared, so let me check my math first. So n times n squared is n to the third. N times 8n is 8n squared. I missed that one. N times 16 is 16n. So see, I made 2 mistakes already. 4 times n squared is 4n squared. 4 times 8n is 32n. 4 times 6 is 64. So yeah, I made 3 mistakes. You don't know this, but right now it is 3:30 in the morning. That's my excuse. Okay, so I have n to the third, I have 8n squared, and 4n squared is 12n squared. And then I have 16n plus 32n is 48n. And then I have the 64 at the end. And so you see this is the same as that. So we got the same answer both ways. Okay, now we have y plus 2 to the fourth, and we're going to just do this the Pascal's triangle way. I don't want to do that again, okay? And so that would be even an additional step because it's to the fourth power. So it's going to be, so a is going to equal, in this case, is going to equal y, and b is going to equal the 2 there. There's the a, there's the b. Okay, see how fast you can do this one. Again, if you don't have Pascal's triangle, you now know how to do it. You know how to create it. But this is to the fourth, so we're going to go to the fifth row. 1, 2, 3, 4, 5. It's 1, 4, 6, 4, 1. I'm going to space them way out so I leave plenty of room. Okay, and our a is the y, so it's going to start off with y to the fourth, whatever that exponent is. Y to the third. And no y there. Okay, now our b is 2. So it's going to be 2 to the fourth. And 2 to the 0 is 1. So let's clean this up. So get rid of that coefficient. You don't write that. And 2 to the first times 4 is 8. 2 squared is 4 times 6 is 24. 2 to the third is 8 times 4 is 32. And whoops, 24. Didn't write my y squared. Okay, and you know, I should have put my plus signs in between. That's why I got confused. Okay, so again, that was 4 times 6 is 24 y squared. Now it's 8 to the third. 8 times 4 is 32 y, and 2 to the fourth is 16. And that's it. Do that nice and easy pretty quickly. Okay, number 14. Here we go. A little blurry here. Let's see what we do. There we go. It's a little better. A plus 3 to the 5. Okay, that's going to be a joy, and you're going to do that one on your own. Okay, so let's look at, if it's to the 5, you got to go to the 6th row. 1, 2, 3, 4, 5, 6. That's 1, 5, 10, 10, 5, 1. Okay, I'm going to get you started there. Leave a lot of space. Okay, and your A is the A, and your B is the 3. Okay, so go to it. You're going to start with A to the 5th over here. And you're going to start with B, which is 3 to the 5th over here. This one goes forward, 4, 3, 2, 1, 0, and this one goes backwards. 3 to the 5, 3 to the 4, 3 to the 3. So I'm going to leave that one. I did half the problem for you there. You go ahead and do the rest. Okay, let's move on down here. And we're going to skip this one. It's kind of an oddball problem. Okay, find the perimeter. This is kind of a fun one. This is practical. You're in construction or something, or you're doing somebody's backyard, building a fence. I've done that and had to do kind of a problem like this. Not exactly like this. It wasn't quite this much algebra, but it was similar. You had to figure out how much wood you were going to need. Okay, so here we go. Perimeter is the distance around. So they want perimeter and area. So what you're going to do is you're going to add this, plus this, which you don't know, plus this, plus this, plus this, which you don't know. But you can figure out those two don't knows. Alright, it's a little messy, but let's go ahead and do this together. Okay, so just think out conceptually, and I'll do the numbers with you here. Conceptually, how would you do this don't know? What do you do? Well, it's the same as this plus this, okay? So it's the same as x squared plus 1 plus 2x plus 2. Okay, so that one we can go ahead and do. So we'll do that off to the side. This one's a little more complicated. How do you do this one? Well, it's the same as this entire side minus this part of it right here. If you take this minus this, it'll give you just that distance right there. So I'm going to write that up here, and that's the one we'll go ahead and do first. So that's going to be 2x squared plus 3x minus 5. Okay, and then I'll put that in parentheses, and then I've got to subtract this. So it's minus, and then I'm going to put this in parentheses. Don't forget the parentheses there. It's minus x squared plus 2x minus 2. Okay, so you've seen problems like that before. Not that hard. The largest exponent we have is a 2, so I'm going to make 3 columns. 2, 1, 0. And I'm going to go ahead and write this across here. And this is going to be a plus. Now I'm going to distribute this minus sign. That's going to become a plus. Or excuse me, that's going to become a minus. That's going to become a minus. And that's going to become a plus. It's going to flip that around, negative, negative. Okay, so we have that. Again, I flip that sign from there, and I flip that sign from there. Okay? Alright, go ahead and add. So 2x squared minus x squared is not 2. It's 1x squared. Three minus 2 is x, positive x. And negative 5 plus 2 is negative 3. Okay, so that is the length of this right here. Okay, so we have that. But I'm going to show you something in a minute, but I wanted you to know how you got that. Now we're going to do this one right here. So this one's a lot easier. I got 2, 1, 0. So there's x squared. That's going to go here. There's a 1. There's no x here, so it's just the 1 goes over there. So you leave a blank space there. That you can do, and that you often do that. Now this one is 2x, so that's going to go here. And 2 plus 2. So now you add these two and you get 3. Here you got nothing there, so it's 2x. And you got nothing there, so it's just x squared. Okay, so we now know this, we now know this. Alright, so let's go ahead and do this. So now we got to add all of these pieces together. But here's the thing. We know that this plus this that we figured out for right there is going to equal that. So we can just use that twice. So this side is equal to this and this. They're the same distance. We really didn't have to do that, but I wanted you to see how it's done, how you would compute that. So in other words, this side is the same. It's just because these two sides are kind of broken apart like that doesn't mean they're not the same distance. That this plus this equals that. So we can just use this number twice, okay? So here we go. We're going to solve the perimeter. So first of all, I'm going to draw arrows so you see. I hope there's not too many arrows here. So it's 2 times 2x squared plus 3x minus 5. Again, why is it 2? Because you're going to use this number for this side, and you're going to use it another time for these two put together for this side. So that's 2 times that. All right? Similarly, now that we've added these two together, and that gave us this number down here for this. This is also the distance of this plus this. So we can also use this twice. Okay, or excuse me, use this twice. So it's going to be 2 times this right here. Okay, so this is a simple distribution. 2 times 2x squared is 4x squared. 2 times 3x is 6x. And 2 times negative 5 is negative 10. Okay, so that's what I got for that. Now I'm going to do the same thing here. 2x squared plus 4x plus 6. Alright, so what do I have with this? I have the total length of this and this together. What do I have with this? I have the total length of this and this together. Put all that together and you have the perimeter all the way around. So I'm going to add these two numbers. So let me just write them down below to make it a little cleaner. This one is that. Okay, and you got negative 10 plus 6 is negative 4. 6 plus 4 is 10x. And 4 plus 2 is 6x squared. And that was a positive there, and that's a minus. So 6x squared plus 10x minus 4, that is your final answer. Okay, so go back and kind of study that, see all the steps that I did there. Again, this was not a necessary step, but I wanted to show you how you would calculate that. So actually it's a simpler problem. It's really just everything down here on the bottom, and there is your final answer. Okay? All right. Okay, I'm going to leave it at that. That's the lesson for 2.01. And go ahead and do that. Now, I really want to look at the ones that I didn't do for you. I want to see that you actually understand how to do these, so it's not a copying exercise. But you'll get most of the credit, I would say up to like a D, C minus, just for doing what I did. And then you get the rest of the credit, obviously, for doing the ones that I didn't do for you. So, but you have an example for each of those. You have an example earlier on that you can see how to do it. Okay, so that takes care of lesson 2.01.